Hello everyone, and welcome back to another concept session for Mat 170. Today we're going to be talking about factor theorem and how to use factor theorem to determine if a synthetic division problem is going to yield a remainder. But just to get things started, first off, what we're doing is just going to talk about real quick an overview of factor theorem. So factor theorem says that if we have an equation p of x, which is the inside equation, if we take p of x and it's divided by something of an equation that resembles x minus c, where c is any constant, right? So that can be any integer value, positive or negative. Okay, if we take that c value and plug it in to our p equation, if it equals 0, that means that there is no remainder. And if it equals anything else, that means there is a remainder. So when we look at the question that they give us, we know that our p of x is going to equal x cubed plus 2x squared plus x minus 10. And our x minus c is going to look something like we have x minus and then our c, which is a positive 2. So we have x plus 2, right? But what we have here in the formula is x minus c. So what we actually need to realize is that c actually equals negative 2, because when you work this out, right, if you multiply a negative by a negative, you get a positive. So really you get x plus 2, which is what we're dividing by, but what we really need that c to be is a negative 2 for it to fit into the equation. So from here, what we're going to do is just follow factor theorem, right? So we're going to have p of negative 2, which means you're just going to plug negative 2 in where all the x values are. So we have negative 2 cubed plus 2 negative 2 squared plus a negative 2 minus 10. And when you work that out, you get the answer of negative 12, which we know does not equal 0, which means that there must be a remainder. And furthermore, that remainder equals negative 12. Okay, so hopefully that was a good little primer of factor theorem. Other than that, that's all I have for you today. So I hope you have a great rest of your day and good luck in your course.